vitamin D. But here are other courses, and we'll hear this from the faculty, and I have the pleasure to introduce to you the members of this faculty. My name is Jochen Eulert. I'm Emeritus Professor of Orthopedics from Würzburg. We are all from Würzburg. Würzburg is in the southern part of Germany. It's a university city, and it's famous for two things. One is the wine, white wine, excellent white wine. And the second is Röntgen. The X-rays were discovered by Röntgen in 1898, and he got the first Nobel Prize for Physics in 1901. So to my right is Dr. Kitz. She is a pediatrician, and she is also an expert in tropical medicine, and she was for a long time consultant in an international health institute, and in this position she got involved with this problem in Nigeria, and she is also the promoter of this research and treatment and all these problems. The second speaker will be Professor Jakob. Professor Jakob, he is an expert in molecular biology. He is a professor of internal medicine and the chairman of the Bone Institute and the chairman of the research department of the orthopedic clinic, orthopedic department in Würzburg. Number three is Professor Raab. He is a surgeon. He is an orthopedic surgeon and consultant in the orthopedic department of Würzburg. And last but not least, we have Professor Sponholz. She is not a medical doctor, but a professor of physical geography, and you will see in which way this specialty is involved in the problematic of rickets under the sun of Africa.
Thank you very much, Professor Eulert. Dear ladies and gentlemen, it is a pleasure to have this session together with you, and I'm also very happy that I see some members of the southern hemisphere of this world where we found the problem, and I hope you may distribute this to your original countries. I immediately start with the session. It is something I got along with when I worked as a consultant for international health in Würzburg, and just by a fax machine, these type of pictures received me with the question, what the hell is this? They came through Miserior. Miserior is a German church charity organization, and a small NGO, non-governmental organization, Hope for the Village Child, announced this problem to Miserior to ask for help. So here we were with this problem, and the first thing was, as a pediatrician, it may look like rickets, but as you all know, it can be also due to many other reasons, these monstrous deformities of lower limbs and rarely also upper limbs. So it was urgently important just to have a look there, to go there, to see what the problem was. So I got confronted with this problem in May 2005, and in June 2005 I did the first initial visit, and ever since then we are all very busy with this problem right now. The country we talk about is Nigeria, and in the northern part of Nigeria we have Kaduna State with Kaduna City, and this is where the majority of the patients come from. This organization, Hope for the Village Child, works in an average of 50 square kilometers in the southern part of Kaduna State, and its name is Hope for the Village Child. And it is a small group with a very efficient outcome. They do lots of different things. They do dwellings, building dwells. They do construct schools also for illiterate adults. They do women and adult school teaching, and they do microcredit programs for families, mainly for women, to ensure a family's safety. During their work, and upgrading numbers has been shown to them in the recent years that they carried out their work in the villages. And this is what they are confronted with. Children, although mainly children with severe deformities of their legs, unable to go to school because they have a severe bone pain and also because they have severe muscle weakness. So they are socially isolated. They cannot help working in the fields. They cannot go to their schools. They have, well, not a very positive future in front of them, I would say. The people that are mainly confronted with this problem belong to the Bagi tribe. That is the main tribe in that region. They live a very formal and, I would say, simple life. The mainly diet they have is a maize-based diet with some vegetables, some meat, and dairy products, that means milk products, do not count for their daily diet. It is an ethnical problem or an ethical solution for them that they don't take dairy products because this would count them to another ethnic group like the Fulani, which are seen as a lower social grade in that area. We see many, many children, up to 40% of the children in that area that show severe rickets symptoms, as you can see here on the picture. But there's also a number of children which live under exactly the same conditions, come out of exactly the same families, that do not have any clinical symptoms of rickets. This was striking. The neighboring tribe, the Fulani tribe, that lives also in the same area under quite simple and same conditions, is the Fulani tribe. There's only one difference: they do drink milk, cow's milk and goat's milk. And they don't show rickets symptoms. So in my initial visit, I visited in June for 1 week that Kaduna South area. We collected already 90 patients out of several villages. And I was able to take some blood specimens as well, and I will show you further results later on. Up to now, we have more than 1,000 cases, and it is just due to restricting reasons from the organizations that we cannot continue with collecting more patients because it's just over the top for the organization, for the small organization on the ground to cope with it. What is rickets? Rickets is, well, in northern parts, mainly eradicated due to vitamin D distribution. So a clinical picture that we are not used to anymore. In Nigeria, rickets is a topic in the literature since 1970, and under the sun in Africa, due to mainly calcium deficiency. That is what we found out, and that has also been found by other researchers that work in that area. So we have the entity that there's a decreased mineralization in the bone. They have retardated growth retardation, delayed skeletal development, and the diagnosis is made by clinical symptoms that I will show to you, certain X-ray findings, and in the laboratory, if available, increased alkaline phosphatate. Radiological criteria, as you can see here, is in the distal wrist, the epiphyseal widening and the cupping and fraying of the metaphyseal margins, the severely decreased mineralization, and massive deformity of the bone putting on when weight is put on the bone. So after the zibbling time, it starts becoming manifest, clinically manifest. Clinical picture is shown here, taken by this child. You see the deformed chest already with the Harrison sulcus, the pot belly, and the deformity of the legs, the enlarged wrists. Here you see the Rickets rosary very nicely, and if you look much more closer, you will see these scars. That is from traditional medicine. Patients with rickets have more often pneumonia, clinical pneumonia, and this is traditional healing, putting on these scars on their chest. There is deformities in all ways that are, or in planes that are possible. So all angles can be deformed. You see X-shape, genuvarum, genuvalgium. You see the windswept in all directions. And sometimes, if I would show you videos, it seems impossible for them that they can walk, but they do still walk under an incredible amount of pain. It is sometimes not only the lower limbs that are involved, but also the upper limbs, or within the lower limbs. You can also see that is in the thighs, and here the severe deformation that really leads to a very isolated and restricted life. We see severe cases of scoliosis. We see the frontal bossing, the pot belly, Harrison sulcus, nicely seen, Rickets rosary again. And you see the severe stunting. This child, it's its 3 younger sister, but she is smaller than her 3 years younger sister. So we carried out first research. We sent some medical students into that area for taking epidemiological data and also to take some blood samples. And this is the first striking slide, I would say, showing the severe stunting. These are the cases, and these are the control groups of the same area, families, sometimes they're sisters and brothers. And those are the cases with rickets, and you see with ongoing age how much the height for age score is decreased. Vitamin D, I don't want to bore you with too much metabolic research, but it's just some steps that are necessary to know. We take up vitamin D with our nutrition. We have 2 hydrolyzation areas, one in the liver, and then the active hydroxylation takes part in the kidney. And then it is active and reflects on many other organs. And the end organ is then, one of the end organs is to mineralize the bone. But Professor Jacob will later on show this more in detail. The forms of rickets, as we know, there's 2 different groups, the lack of calcium and phosphate depletion that are common and well known. So calcepenic rickets form show mainly vitamin D deficiency or calcium deficiency in one of those organs where the hydroxylation takes place. If there is any disease there, can also lead to rickets. So if we have hepatobiliary diseases, gastrointestinal tract disorders, or chronic renal failure, generalized tube disorders, this may lead to rickets. And then we have some drugs, anticonvulsant drugs may also lead to rickets if it's taken too long. And we have congenital forms, and those were, of course, very important to us, vitamin D-dependent congenital forms, type 1 and type 2. Phosphate depletion is also due to, for example, primary mineralization defects or malignancy-induced rickets or congenital or acquired renal Fanconi syndrome. And in preterm babies, we have a physiological lack of phosphate leading to rickets if we do not treat it. The genetic forms, type 1 and type 2, go along with lack of enzyme activity of the 1-alpha hydroxylase on the chromosome 12, which is autosomal recessive, and type 2 is a homozygote mutation of the vitamin D receptor gene. It's also homozygote recessive. These parts go along with alopecia, which was not found there, so that was not a candidate, but this could have been a real candidate. Seeing the problem, we also had to set up a plan of action, so we decided with a group of researchers and workers there to do a study to analyze the underlying problem and to immediately implement a treatment option for the patients with drugs and also with surgery. And a third and the most important column is the prevention of this disease, to implement preventive means after we found out the reason for it. So we went into Nigeria, southern Kaduna State area, which is extremely isolated, did lab tests there, or we collected the blood samples, deep freezed it with minus 70 degrees in the sun of Africa in the village, which was quite a challenge, I must tell you. And then we received first results for biochemical measurements. Here we see the severe decreased calcium. These are the unaffected siblings, where you see an average of 2.2 micromole per liter, which is a low normal range. And if you go to severely affected siblings, you see the average is at 1.8 micromole per liter, and there are even some candidates, they have less than 1.3, which is really something that we would not see here. Parents' generation have, like the unaffected siblings, a low normal range. Serum parathyroid hormone is increased in severely affected children over the normal range, and all the others have here lower numbers. One aspect, hyperparathyroidism of Rickets, which shows the proof. And here, the active form of vitamin D, again in the affected group, a very high level, showing the trial of the bone to make the most out of it, to mineralize the bone at its best with active vitamin D. And a low pre-form, the 25 vitamin D, which we interpreted as it's so much used up that is as a lower grade than normally. These results led us to the question to investigate this further on. Is there any genetical aspect for it? Because we saw a group of children that led us to the impression that it looks like an autosomal recessive disease, and therefore we asked Professor Jakob and his group of the Orthopedic Musculoskeletal Center of the University of Würzburg for help, and I would like to hand over this to you to continue for the next. It is a teamwork lecture, so I will come back to you.
So, thank you for introducing me, and good afternoon to everybody. I would like to address the background of molecular biology and also a bit of gene-environment interactions on our search for candidates which might be involved in the susceptibility of these patients for hypocalcemic rickets. If you look at this trait of the affected children, you might be quite sure that it is a sort of autosomal recessive trait, and you look, of course, for the candidate genes which mediate this susceptibility. Now, the first candidate, of course, would be vitamin D receptor signaling cascade, and all genes involved in this signaling cascade, even if it is only heterozygous mutation which might be associated with this susceptibility. It is quite clear that if there is a genetic susceptibility, it can be clearly overcome by conservative treatment, as you will see in future in the consecutive lectures. But still, we would have a lot of new knowledge on the regulation of calcium metabolism if you would get hold of these candidate genes. So we cared, as I said, for the vitamin D receptor, and we were not the first ones to do that. A different population in Africa was also analyzed for polymorphisms in the vitamin D receptor. As you can see, The main signals of vitamin D receptor signaling together with vitamin D, 125 vitamin D, is a nuclear signal mediated by the vitamin D receptor itself and the retinoic acid X receptor. And there are several signals also mediated by membrane-associated receptors, which lead to a different spectrum of gene regulation. So we choose the obvious candidate, namely the vitamin D receptor, and looked for polymorphisms in that receptor gene. If you take the whole chain of signal transduction for vitamin D signaling, you would have to take into account also the metabolizing enzymes, which are obvious candidates, like the enzyme 1-alpha hydroxylase, which hydroxylates the 25 vitamin D3 into 125 vitamin D3, and is the central enzyme to support the organism or to supply the organism with active vitamin D hormone, and this is active vitamin D hormone. We could rather exclude these candidates in the vitamin D in the vitamin D metabolism itself, because as you could see from Krista Kitz's slides, the levels of 125 were even elevated, indicating that at least the enzyme was active and was not a candidate for the susceptibility as a susceptibility gene. Now, what can mouse genetics tell us about vitamin D receptor signaling? And this might be important with several aspects. So I give you some words on this problem. Classical rickets, as you know, is the clinical syndrome of diminished vitamin D receptor signaling, and it's not the classical form, which we are talking about here, namely calcium deficiency rickets. And as you can see, the vitamin D receptor knockouts resembles quite well the human disease in the rare cases of vitamin D receptor mutants, which occur only in a handful of families on the world, and these mice also have a complete alopecia, as you can realize here. Now, if you look at the main phenotype of these vitamin D receptor knockouts, the main phenotype of vitamin D receptor knockout in the growth plate of the tibia of these mice is a completely disorganized and disturbed hierarchy and structure of the growth plate. The very surprising facts that were delivered with the phenotype analysis were that if you give these animals a rescue diet comprising a very, very high amount of calcium and phosphate, you can almost completely rescue this phenotype. So this tells you that the main phenotype or the main clinical effects of the vitamin D receptor are intestinal, in fact, and that you can rescue the vitamin D receptor signaling partly or to a certain extent, as you can also see here in the length of the femur, if you give a high calcium diet. So both vitamin D receptor signaling and calcium diet can modulate the bone phenotype in this context. And if you conclude from these data, you can conclude that the intestinal effects of vitamin D receptor are the dominant and very important ones, and a calcium-rich diet can largely overcome the phenotype you can cause if you knock out the vitamin D receptor, telling you that calcium intake is really very important and can also, as you have already seen, can also cause rickets, clinical rickets. Both the gut and bone cells are definitely vitamin D responsive, but I won't go into details here. And the non-genomic, so-called non-genomic effects mediated by membrane-associated receptors might not even be important in this context, but we don't know very much also about these effects. Now we went on and looked for common polymorphisms within the vitamin D receptor gene, which is depicted here. And you can see several known polymorphisms in the human genome which mediate reduced or altered vitamin D receptor signaling, like this polymorphism in the promoter region, like this one, which creates a shorter vitamin D receptor gene, receptor protein, and like this one, which is located in an intron, and we don't really know what it does, but it is associated with signaling. To make a long story short, we, as the other groups working on that topic, did not find any evidence for any of these polymorphisms to be associated with this type of rickets. So we had to and have to look for new candidates in this context, and I come back to that at the end of my short talk. In the second part of my talk, I would like to give you some words on the interaction of trace elements and minerals in the human body. We have previously been working already about selenium and its impact on vitamin D receptor signaling and its impact on bone metabolism in general. And there is a model disease which is in Central Africa and in Southeast Asia called Cashin-Beck's disease. It's an osteoarthritis which is not caused but severely modulated by selenium deficiency. And if you supply selenium, you can really alleviate these symptoms. Selenium deficiency in animals is associated with osteopenia, and I remember you on the calcium metabolism and calcium balance in these patients. In selenium deficiency, these animals lose calcium via the kidney. And the third important point may be that selenium-dependent enzymes are expressed in bone cells. And for those of you who are interested in selenium biology, I should tell that the human organism has at about 25 selenium-containing proteins, and these are enzymes which carry a characteristic amino acid in their amino acid sequence. It's a selenocysteine, which is only incorporated in the presence of such a complicated 3' structure, a so-called C-cis element. Now, in selenium deficiency, as we could show earlier, in cell culture, if you keep the cells selenium deficient, you don't get stimulation of one of these enzymes, in this case, thioredoxin reductase 1. And if you supply selenium in the culture, you can see that vitamin D has a profound impact on this activity. This I want to give you as an example for the interaction of trace elements and minerals and vitamin D metabolism, which we can also show in cell culture. Now, going back to the children in Nigeria, I was immediately remembered of Cashin-Beck's disease when I saw the X-rays, and I said we should look for the selenium as a trace element in those children. We have performed earlier experiments or clinical studies in osteoporosis patients, and we saw that one enzyme in the serum, which is glutathione peroxidase, and this is selenium dependent, is low in osteoporosis patients. And when we looked for this enzyme activity in the Nigerian children, we saw even lower activity, indicating that they not only have calcium deficiency, but also severe selenium deficiency. And when we looked for the selenium atom itself by spectroscopy, we saw that these parents had low levels, and the affected children had even much lower levels. And if you compare that to for example, German controls or Scandinavian controls or even North Americans, you can recognize that this is really a very, very low level of selenium. And we can conclude that this deficiency probably interacts with the obvious calcium deficiency these children are suffering from. So I summarize and conclude that nutritional calcium deficiency is the most important mediator of this form of rickets. This is quite clear. But as we have shown, additional trace element deficiencies might contribute and even transport or mediate this important contributors of this disease in that they even make it worse. We still have to look for genetic candidates, and since we didn't find associations with vitamin D receptor polymorphisms, some of the genes involved in vitamin D receptor signaling cascade are of course still candidates, but also other candidates are the proteins active in calcium balance and metabolism, like the intestinal proton pumps and chloride channels, because gastric acid mediates the efficiency of calcium absorption and also the epithelial calcium transporters. And last not least, it might even be that selenium-dependent enzymes might be genetically altered to support this susceptibility for calcium deficiency rickets. And I thank you for this part, and Krista Kitz will take over again.
Thank you. The intermediate intervention for these children was to put them on drugs, the well-known combination vitamin D plus calcium. So this was immediately given to all children. But as we received the first laboratory results, we also thought maybe it works with only calcium. So that was what we did. We conducted a study group of 50 patients in each group, and one received calcium plus vitamin D, and the next one received only calcium. It's not working anymore. Maybe the battery's off. Ah, okay, somebody turned it off. Okay. I just want to show you some pictures of the threatening impact of this treatment and of new aspects of this treatment. What we see from literature and also from recommendations from other researchers in Nigeria and in other countries where this problem is coming up, the main message was showing children, was giving treatment for a period of 3 months. And this should show you that giving the treatment for a longer period, even 1.5 years or 2 years, still brings up better results and shows the dramatic normalization or normaling of the shape of the bones. Each of these cubes here measures 5 centimeters, so you can see, as they are in the correct position, how much the legs straightened just on time, on a time scale, when we gave them calcium. And it was, of course, a very striking result, and for the children in that area, a wonderful come out. And we had, due to this effort, no problems to continue with our studies and to be respected in the right way in that area. Mainly the genovarum position showed the best improvement under medical treatment, but also here is a windswept deformity that normalized quite well and improved a lot, or X-shaped. So you see that giving calcium for a longer time than so far known has a great impact of the improvement. The earlier we start this kind of treatment, the better results we have, and this is shown in this picture of that young boy. But still, out of the patients, number of 10% to 15% needs surgical interventions, and that was the next challenge, to find somebody who would go to Nigeria to operate in Nigerian theaters with this kind of surgery. And we had the pleasure to find Peter Raab from the Orthopedic University of Würzburg, who came along for an initial visit. He still had the time to decide if he would do it or not. But after being confronted with all these children, he had no other choice but just going there. And I'm very happy, Peter, to hand over to you and to show what you did with the surgical parts.
Ladies and gentlemen, dear Professor Eulert, thank you for invitation here to Gothenburg and to have the opportunity to present our Nigerian story. My part is to talk about surgery in severe cases of rickets, and This one. And as Krista said, when we came down in May 2007 and saw all the variability of deformity, we were very impressed. As we learned to know that under medical treatment, the natural cause of remodeling of the leg axis occurs, we were very happy, but we also saw patients with a very high-grade multidimensional and combined deformities where the normal remodeling will not take place anymore. So the necessity for surgical intervention was definitely necessary. So it's not only a cosmetical, as Krista said, or functional impairment, but something that leads to social isolation. So we had to go on and to look for a partner where we can do the surgical therapy. And we found the St. Gerard Catholic Hospital, where they offered us one of these twin theaters to do surgery there. And this was the initial view inside the theater. It was not very bad looking, and then we were confronted with the instruments, and in this instruments we thought we should not do responsible surgery for these children. So some preparations had to be done in the theater, and some equipment had to be implemented with donations and with money from the special institutes Krista mentioned already, so that we are independent from AC/DC, and we had an OP table and lots of instruments to perform surgery there. And then the thing was to develop a form of strategy in these cases, and we thought a single-stage substructive multidimensional and multi-level osteotomy with minimal osteosynthesis would be the best to do there, to take Kirschner wires, for example, because they are cheap and they can be taken out very nicely afterwards. Or like those devices with an intramedullary nailing with the osteotomies done on the tibia, for example. So in the 2 years we operated on 27 children. It was 45 lower extremities, and they all had 2.4 years of medical treatment. And you see it were mostly genovalgum deformities and genovarum deformities, but also the anticurvation of the tibia is operated in 7 patients, and there were also combined deformities. We did 36 osteotomies of the femur, 27 of the tibia, 25 of the fibula, and there was also soft tissue surgery to be undertaken in most cases to realign the patella. So I go into details and show you the patients. That is Sarah. Sarah is almost 19 years with this very big amount of valgus deformity, and she couldn't marry because of this problem. And we did surgery on her, taking out this piece of bone in the right dimension, putting in those Kirschner wires, and then closing the osteotomy to have the leg straight again. And the Kirschner wires were brought in through the medial condyle, and you can take out the implants through a small incision in this area then again. We put on a plaster cast afterwards, and you see her smiling, and all the children were mobilized then with such a device. after surgery. And here you see Sarah at the follow-up. The leg is straight, and we have X-rays preoperatively which didn't show the deformity in the correct way because of the positioning on the X-ray before they don't have the experience, the X-ray department there. But you see then the clinical and radiological result. Lara had both legs involved. You see the severe genua valga. We did the same type of osteotomy, and here you have to do a lateral release for centralization of the patella. And here the right leg is operated, the left leg will come later. And you see the clinical pictures preoperatively and postoperatively, and you have to look at the foot positioning. And this is not the patella, that's the medial femorocondyle, and only with this sort of positioning of the leg they can walk a little bit, and that's after surgery. So, and to prove that a bone is healing, we have done X-rays after surgery, but now that's only the initial pictures we did then postoperative surgery. Okay, and also the young males have those kind of deformities, the valgus deformities, and bullous after surgery is now keen on playing football. Press something. Oh Gott, was habe ich jetzt gemacht? Okay, thank you. The next deformity are the genua vara deformity. You see here an inward rotation up to 90 degrees in the tibia. That's direct postoperatively pictures here with a cast on. And we performed a chevron-like osteotomy on the tibia to correct the varus and the rotational deformity. And you have to prove the right knee foot alignment directly intraoperatively to have the right definitive position. And you see here Deborah, she was operated in this way, and what is essential is that you do an overcorrection in a slightly valgus because the lateral capsule joint complex is very lax, and you have the risk of relapse. And they gain height and I think some sort of self-consciousness. The combined deformities like genovalgum on the right here and the varus and inward rotation on the left tibia are operated in the same way. You see the direct postoperative pictures. And the clinical follow-up shows this situation. You have to look on the shoulder girdle, which is standing now in a horizontal position, and the bone is healing, and the joint plane is in the horizontal position. Christiana is a case I'll show you because the deformity in her is not in the tibia, but the varus deformity is up here in the femur. So we had to go to the femoral bone and to do an osteotomy on the diaphysis under this condition is very risky. So we went for this to go for a femoral diaphyseal substructive osteotomy. And then the rotation deformity is left, so we did an distal tibia derotation osteotomy to get the right leg axis again, and that is the clinical outcome. You see the position of the shoulder girdle, the pelvic obliquity is away, the scoliosis is diminished, and the foot position is in the right way. The undercurvation of the tibia is, we had in 7 cases, and here you see the clinical aspect and the X-ray, and if you see the joint lines, it's almost a 90-degree of deformity. That means you have such an saber shin deformity, and here's the left leg is operated, and the right will come just now. And you see we have to do multiple osteotomies, and we put a nail in it, an intramedullary nailing. All the surgeries are done without X-ray control, so you need another one for reference to have the right length inside the bone. And in this, you have also to check the knee joint, the knee-foot alignment to have the right outward position of the foot afterwards. And Emmanuel improved very well from this kind of operation in the beginning, walking with a stick, and afterwards you see here with a cast on and with a walker, quite unsecure, but the follow-up again, he was quite happy and smiling and running around. This is the clinical preoperative and postoperative picture, and in this case we also wanted to be aware that the bone has fused in the right way. You see the lateral picture. Atuna, the last patient I want to show you, that was really a challenge because she couldn't really walk and couldn't really stand. She had always need any support, and you see this big amount of deformity, which is not only in one plane but really in different planes, and we didn't know how to put her on the operating table. She has a valgus deformity here in the distal femur additionally, and we did in the femur the same osteotomy as you heard before, and the intramedullary nailing in the tibia. And so she had an operation with 10 osteotomies, but after having the casts away, she was smiling about her result and was able to lift up the leg for herself. And you see the correction in the AP and in the lateral and in the AP view. And this is the clinical picture afterwards. You see the position of the foot now is corrected, the deformity is corrected, and she could stand and walk in a quite well manner. But that's not a, we have a team who has to work together, and Sister Maria, the nurse, who is coming down with me, he is with us in the surgical team, and Dr. Igo, he is an orthopedic surgeon from the area, and Bridget, she's from the hospital, and that's our surgery we did there. Thank you.
Thank you, Peter. As you saw in those pictures, you can maybe imagine that most of these children were not even able to walk because they didn't know how this goes. They had not made the experience of walking upright in all their life, so they had to relearn this or learn this from the beginning. So we did lots of physiotherapy on them, which also is not mentioned. And we investigated the bones as well. We wanted to see how was the outcome after a long period of medical treatment and after the surgery. So the surgical biopsies were investigated, and with the courtesy of Michael Emling, who did this in Hamburg for us, it was shown that even after 2 years of medical treatment, there was still a high number of revealing osteomalacia, and also bone marrow fibrosis, which is an indicator of still existing hyperparathyroidism, a form of active rickets. The third column, and for me as a pediatrician, the most important column is the prevention. How can we implement preventive means into that area that this type of disease is not coming up to that extent, that we may not even need surgery in the future anymore, hopefully, because it is a dramatic interruption in their life. So a preventive mean, due to the studies, is a striking result again, because it is the most cheapest and the most simple way to deal with this problem. It is just giving calcium. Calcium to all children up to the age of 2 years, for example, and as we know from literature as well, the bone is mineralizing in the last 3 months of pregnancy up to 80%. So we need to give calcium also to all pregnant women and breastfeeding women. This would be a perfect prevention, and we need stakeholders that play a major role to distribute this to the population, which is very difficult. A last area, or another wish, would be food fortification with calcium. We know this very well from the iodinization of salt, preventing goiter. This is the primary healthcare success story of the last century, and giving calcium could be the one of this century. A reasonable challenge that we would like to follow. So lots of things to do. Of course, we need to give this information to the population to make it understandable to them. So we made up lots of drama games and information tables in their local language, how calcium is, or in which numbers of foods calcium is implemented. And we gave talks here. This is the king of the Bagi tribe, who fortunately studied in England, so he was well achievable and approachable. It was a nice experience to sit together with the king of a tribe and to share this information with him. We showed here the King Peter's results of X-ray after theater, which also had a good impression on the king. We went into television and radio to distribute the information into the country. We went to the First Lady of Kaduna State and the Minister of Health. This is the First Lady, this is the Minister of Health, and this is Sister Rita, which is the leader of the local NGO, Hope for the Village Child, to share the information. But it is a critical condition, and we will come to this a little bit later, maybe also in the discussion, how we can distribute this information and how we can implement treatment and preventive means. After all this research, we still had the thinking, this can't be all of it. There must be other figures contributing to this problem. It is not only genetic, because we have healthy children which live under the exactly same condition that show no symptoms of rickets. And this led us to the point that there must be some environmental factors playing a role in this problem as well. So we had the pleasure to find Professor Barbara Sponholz from the Geological Institute of the University of Würzburg, who had done lots of research in Niger, the neighboring country, and she was very willing to help us and was herself very interesting in finding out what was the environmental part of it. So I hand over to Barbara.
Yes, ladies and gentlemen, I'm very happy to have the opportunity here to round up this afternoon, this session. And as a physical geographer without any medical formation, it was for me really a very strange question to find an area in central Nigeria with an appearance of 30 years about, of children with such deformities. And when I heard of it and that it was a calcepenic rickets, I said, well, perhaps the soils are tired, because in tropical areas, soils are developing otherwise than they do in temperate regions. So together with two students, Lena Hartmann and Valentin Eich, I went to central Nigeria in 2008 for 3 weeks for a first study in this area. And it was mainly Lena Hartmann who has finished her study thesis about this analysis of the project. And I'm mainly presenting her results of this thesis in this afternoon. So how is the calcium input in the people working, and how is calcium going away? Together with selenium, I just put a little remark on it. Under such conditions in tropical areas, wet tropical and mostly wet tropical areas near the equator. So we have in green marked the calcium and selenium input. So it comes mainly with Harmattan dust from the northern parts of Nigeria and mainly of Niger and of Chad area. So from the Central Saharan parts with completely different dry, arid climate, weathering conditions and transport mechanisms. So this dust is arriving in the tropical areas and enriching the soils with calcium and other mineral materials. And the second important way to get calcium into the soils is weathering, chemical weathering from the basement complex that's mainly in central Nigeria made of granitoid parent rocks who contain small quantities of calcium. They have larger quantities of silica and of feldspars, but very low contents in calcium. So they are not enriching so much the soil. How is the calcium and selenium loss working? So it's mainly caused by the high precipitation during the rainy season that involves washout from the soil, washout of any lightly soluble material. And parts of this calcium are fixed at aluminium crusts. Part of the selenium are fixed on iron crusts. These crusts are also forming under the wet tropical conditions. And this precipitation during the rainy season is about the double quantity that we have in Germany, for example, given. As people only take up calcium and selenium by the food and by drinking water, they, as Krista told, they don't eat or eat very little meat, no dairy products, so animal food is not really important for those people. Plant food, vegetable food, is the main food that they take, mainly maize. Maize itself has low quantities of calcium inside, and there's an important parasite named striga that takes from the roots of maize larger amounts of calcium away. So we have to look how the soils are working, how the calcium is present in the area that is important for the roots of those vegetable plants, and for feeding people and animal. So what did we do? We took interviews with older people from the villages who know very well the development of those area, of the village, of the economy of the people, daily life use, and so on. We took soil samples, maximum depth about 60 centimeters, that corresponds to the plough or shovel depth. Parent rock for being precise for the weathering conditions. Then we had water samples, drinking water from rural wells, surface waters or rivers, and some smaller lakes, and water tanks. We had plants and seeds, mainly corn, but also sorghum, millet, manioc, and also the parasites, mainly striga. And we had some common fertilizers as samples, some ashes from the fields and the households, and one Harmattan dust sample. So we took the calcium quantity inside all these samples and also the selenium quantities in some of them. Oops. Our methods were quite simple, so we took cores here in the upper decimeters of the soil, and sometimes we were lucky to have big cuts of soil deposits. And we went into 5 ricket-concerned villages like here, and one comparison village named Dakala, where we had no rickets in the same Bagi population. So what did we find in the soil analysis? Here you have 3 of the villages compared, It's Dakala without rickets appearing, and Ungwanfada and Shankasa with rickets, with severe rickets. And you have always one core surrounded by the colored circle. And from the upper surface to depth, the points of analysis. And so you see that the percentage of calcium in all those samples is very low. Someone here is higher, I will just speak about it. But normally in the rickets-concerned samples, ricket-concerned villages, the samples are very low in calcium. In Dakala without rickets is also on a low level, but systematically a little bit higher. And this family in Ungwanfada used calcium-containing fertilizer. And this family had no rickets among the children. So evidently, everything here is just with quite sophisticated methods to do. Normally, with common methods of calcium analysis, it's below the measurement precision. But here we see that on a very low level, we have important differences, perhaps at about 0.3% of calcium content in the samples, in the soils. We have a critical aspect for rickets in those areas. Also for other elements, we made bulk sampling. We had titan, aluminium, and iron and manganese, mainly in the crusts, where the calcium and the selenium is fixed. And in the free soil, important for the plant roots, we have very, very low contents. Selenium is nearly not measurable. And also the calcium points are here, calcium is in a very low part. In drinking water, we have also taken in all the villages our samples. And we have here in Germany medium values of about 40 to 50 milligram per liter. Here in the Nigerian villages, we have normally very minor quantities. Just in Dakala, the comparison village, again, and in Kafari, we find a little bit more calcium, but also on a very low level. Selenium was also analyzed in the German Geological Research Center in Hanover, and it's in all samples that we have done below 0.1 microgram per liter. That's the limit of determination in all the drinking water samples. So what did we conclude from these results? First, we have parent rocks that are very poor in calcium. In Nigeria, mainly granitoitic rocks. And together with the intensive chemical weathering, the soils that are resulting from those parent rocks are very poor in calcium. Second, the calcium input by aeolian dust from the north, harmattan, is not sufficient for natural fertilizing in those areas when the fields are permanently cultivated. In areas, example given in Dakala, in the comparison village, where there are long terms of non-cultivated fields, the harmattan dust is enough for enrichment of calcium for a persisting quantity. In the permanently cultivated areas, it's not sufficient. Groundwater and drinking water does not contain or nearly not contain calcium because the washout inside the soils is too strong. Permanent cultivation and fertilizing of the fields started at about 30 or 40 years ago because of the very strong population growth that was initial in this period. And therefore, also the problem started a little bit later when the mothers have not been fed enough with calcium, I think. That's one reason. Because the oldest patients in large quantities are about 20 years old, so it was later than the starting of fertilizing. And from economic view, the most people just use NPK fertilizer, so no calcium is inside, because the calcium is not so important for the plant growth. And most of the people cannot buy the Campa fertilizer that contains calcium because it's more expensive. So just poorer people are using this NPK. And I had shown in one of the pictures the analyses that have been a little bit higher calcium content. That was a family that was cultivating with this NPK plus calcium fertilizer. So what can we transfer the results, and which is possible as a transfer? Unfortunately, we have to say that yes, we can transfer these results from the physical geography point of view at least, because in regions that are characterized by acid, that means silica-rich parent rock materials such as granites, for example, under humid or semi-humid climates and under high temperatures, when it's intensive chemical weathering conditions, and that means we have the low latitudes up to about 10 degrees north and south from the equator. Then calcepenic rickets is emerging, enhanced by minor selenium contents, when it starts to get an intensified land use, and this is normally correlated to increasing population growth, when the calcium loss is not balanced by calcium fertilizer, putting calcium on the fields for food production, or by medical treatment. So what we have to wait for, unfortunately, is that rickets, calcepenic rickets, may occur mainly in this area here, up to about 10 degrees north and south, plus in an area in Southeastern Asia and India, where the monsoonal influence of the climate is also very strong and leads to finally the same conditions like near the equator areas. And here in red and reddish colors, you see those areas who are characterized by acid rocks, silica-rich rocks without much calcium content. And so you see that many of these areas are just waiting for an outbreak of rickets in the next 10, 20 years. So with these words, I will give back to Krista. And thank you for attention.
Maybe we should just add these risk areas of vitamin D dependent rickets, which would then look like an arrow here and another arrow up to there, to show which part of the world is in a risk of developing rickets, which shows a large amount of people. And it is what Barbara said, we can expect that within the next 10 to 20 years in these equator belt areas, this is already happening. We do have good results from the literature again. If you go into the literature and look around, you will find, like here in Bangladesh, groups with severe rickets again. Also from Colombia, we have the same pictures from the Philippines and South Africa as well. So it is really just something we have to wait for, that it bursts out to a major problem. What could be strategies to eradicate rickets in the equator belt in the 21st century? That is something that is now the hardest part to work on, because within the 5 years we have defined the reasons for this problem. We have found treatment options, and what we have not found is partners going along with us to act against or to fight against rickets. That would be local authorities, Ministry of Health, WHO, and the political willingness of a country where this problem occurs. Unfortunately, the Bagi tribe is an ethnically very low esteemed tribe, so it is difficult in Nigeria to get some help for these people. It would be different if they would be in more socially valued population parts. So first of all, to define risk areas worldwide is one of the task we should work on with worldwide research, which is carried out by Secret Strategies already. And as I said, political willingness of a country is the most important part. If there is no political willingness to do something against it, then we will have no choice to target this problem any further. Involvement of WHO, certainly. WHO has lots of wonderful concepts to point on certain diseases for mother and child health problems, but rickets is not in their list, so that should be put onto their list. And then the implementation of calcium distribution could be carried out for those target groups, as I said, pregnant women and children up to the age of 2 years, in already existing health infrastructures. That means in mother and child health clinics, in under 5 clinics, that when a child comes to vaccination day or gets deworming medication or vitamin A distribution, they could just add on to give calcium in those appointments. We need instruction of national and local medical societies to work together on this problem. And we certainly need to have an involvement of local pharmaceutical producers, partners that produce just pure calcium, which is cheap, easy to produce, easy to store, and they just would need to do it. And a very future aim would be the food fortification with calcium, as I said, comparable to the global success story of iodization of salt for the fight against goiter. So far on this project, many agencies or institutions have been working together, and all to mention would take the long, but you see, and you've heard now from many of us who is working in this group, and we need to have more partners to be more efficient. And we dearly thank to all partners that so far worked together with us. First of all, of course, the people from the Hope for the Village Child and the patients themselves and their families. The University of Würzburg, where we found amongst the institutes really very professional partners to face this problem. The Medical Mission Institute as the consultancy of international health that started this together with Miserio as a charity donation agency. And in London, the St. Bartholomew Institute that carried out the biochemical measurements for us in the beginning, and in Kaduna State, the St. Jared's Catholic Hospital, where we carry out the operations. So we hope this afternoon that we showed you a problem that we thought we have eradicated it, that it is not at all eradicated. It has another reason. Calcium deficiency is the striking reason for it, and it brings up a new therapy option, other means to fight against it. And the good news is that we do have options how to do it, and we bring people back into their life. We put them back onto their feet, that they can lead up a normal social life. They can go to school, they can marry, they can have children. And this is the wonderful part, I think, which kept us all going. Also in some areas where we thought it is not really easy to continue with all the obstacles that were put in our ways as well. But we thank you, all of us, very much for your attention, for the long time being with us, and would like to share many points in the discussion coming up, and we would like to ask you to use the microphones that all of the authority of the auditorium can listen to it very well. Thank you very much for your long attention. Genau. Peter, komm mal hoch. Klar. Komm mal. Ja. Yeah. Maybe we should
Thank
just
you
all sit up
for
here.
this wonderful symposium. We have a couple of minutes left for questions, comments, whatever you want to add to that. Please, go ahead.
I am Dr. Vijay Khariwal from India. This is really a very wonderful study, and I compliment you for this. In your investigation, you have left one very important thing which you should have incorporated. That is 24-hour urinary excretion of calcium, which you have not mentioned. 24-hour urinary calcium excretion. That should have been taken. It would have made the study more authentic, because we should rule out the renal factor also, whether it is playing the part or it is not playing the part. And second part is, when you are doing surgery, you are giving medical treatment. Few patients you could have easily done stapling along with the medical treatment. That would have avoided a major surgery, osteotomy like any other thing. And thirdly, I would like to ask, you did osteotomy at multiple levels. Did you come across any case of skin sloughing or compartment syndromes in your patients?
To the first question, we did investigate the urine, the 24-hour urine in patients, which showed a normal excretion of calcium, so there was no sign and symptom of renal failure or renal participation. And the the surgical question, maybe Peter, you should answer that.
I only got the third question. We had no compartment syndrome. We put the plaster cast on, and the plaster cast was split up, and we checked but we had no, really, we were lucky.
Nice. Any comment about stapling along with the medical treatment?
Okay. The stapling can be an option. We do it in our hospital as well, but in this condition we don't have the survey, and so we are not every time in front to, if there's an overcorrection or something like that, to take them out again. So that is an option, but under regular survey.
Yes, please.
Thank you very much for that wonderful symposium. In fact, I've never seen so much rickets in my life as I've seen up there. And I was just wondering, of course, there are some cases there which I wondered whether you thought of Blount's disease, and also some physiological bowing of the legs and all that, but I'm sure all that was considered. What I wanted to know from the surgeon is, what was your age limit for osteotomy? Because we have had the cases where after osteotomy, you find the limbs start growing in the opposite direction as a result of stimulation at the level of osteotomy. And then, how did you deal with the soft tissue in the areas where you had to do multiple osteotomy for a very bent limb? Because that actually seems to be a source of worry. And what are the guidelines for whether you osteotomized the femur or osteotomized the tibia? Because I saw there are some cases you have actually osteotomized the femur and osteotomized the tibia, or a combination of both. And for the pediatrician, I saw that you had actually the king. I hope that you have actually convinced the king now to let the children drink the milk. So what I don't know, this milk, now that the soil has so little calcium, does it contain calcium anyway?
Okay. First, the age limit is, we also operate on very young children, that's true, but they all had at least more than 1.5 years medical treatment before, so we see whether there is a remodeling takes place or not. If it is so, we don't do the surgery. If there is no remodeling over the examined period, period, we go for surgery. And it depends on the severity of the deformity. You don't imagine that almost 60-degree valgus deformity will remodel over the time. It will not. And if you saw the pictures of Krista Kitts, where she showed you the remodeling through medical treatment, at least there are some residual deformities left. So in those cases, we go for the correct axial line. And the other thing was, when we go for the femur and when do we go for the tibia? That depends on the clinical examination. The X-ray doesn't show the deformities quite very well because the X-ray department just put the leg like it is, and the clinical examination decides where to do the osteotomy, because you can exactly determine where's the joint line and is the deformity in the distal femur, and that's the way how we decide.
Thank you very much for your question about the calcium in milk in that area. We certainly also had made this as an issue, and other researchers, Tom Thatcher and Orgini, a Nigerian researcher, they made investigations on that. And they showed that in women's breast milk, the calcium level was already very low. But in like cow's milk or goat's milk, the calcium level was also lower than normal. But all the children, like the Fulani tribe, that do drink milk do not develop rickets. And this is, I think, due to what Barbara found out, the sort of cutoff range of lowest calcium that is still tolerant for a population's group not to develop rickets. It was a marginal gap, the 0.3 up to 0.2. Within this area, we then saw the upcoming of rickets, of clinical rickets, and I think people that drink milk do get more calcium than this amount, so they do not develop the disease. As you mentioned, the king, it was, of course, an issue to see the king, to inform him, and to get his authority to go on with the project. And we were very happy that he was open for it, and he was grateful for the work we did on the children of his tribe. But making them drinking milk is another step that will take a long time and much of convincement. I don't know if people, as white people, will really be able to do this, but maybe that comes up amongst themselves with the time coming up.
There was a remaining part of the surgical question concerned to the soft tissue problems. I mean, the secret is probably in the correction goes always with the shortening. So the soft tissue problem is not that much.
That's correct, yeah.
Are there any other comments? Where are you from? You haven't seen so many. Are you from Nigeria?
No, I am from Nairobi, Kenya.
Okay.
Yes, and I was just wondering, is there any place for bisphosphonate in the older age group? Bisphosphonate.
Bisphosphonates.
Bisphosphonate. I think it is too expensive, and we didn't have this as an option, and we found out that calcium only just plays the major role, and it's enough.
It doesn't help.
And
It won't help.
Yes, please, go ahead. Which part from India you're coming?
yeah,
I'm
it's calcipenic.
from
not
Punjab.
bisphosphonate.
Western part of
Yeah.
India, not northwest part.
Uh-huh.
Punjab. Delhi, near Delhi.
Ah, yeah.
I just want to make one comment. I have a study of near about 1,000 cases of calcium metabolism disturbance, even in adults, and in very high socioeconomic status and other people. And what I have found that subclinical form of osteomalacia, this is also a very important factor for even in high societies, Vitamin D deficiency, I have seen, it is in almost 65 to 70% of the young population, the level is low. And they respond very well when we start with the calcium treatment and vitamin D treatment. So it is not only, but if you go for detailed calcium metabolism study, even in higher society, this air-conditioned culture, young girls, 20 years, 30 years, coming with backache, MRI shows disc, but you do calcium metabolism, you will find there is some disturbance in the metabolism, whether alkaline phosphatase is high, whether calcium is low, whether DEXA score will help you. But if you do all these things, you will find somewhere some problem, and they definitely respond to vitamin D and calcium. It is not only in poor country, in people living in high society, they are also facing this problem. I just wanted to make a comment on it.
Yeah.
Yes, you want to comment on this? Because he is our specialist for hormones.
I think it's quite important to mention that we did only talk about the problems arising in the youth or in adolescence. If we talk about older people, of course, much less degrees of osteomalacia will be a severe risk factor for osteoporosis. And if these people get old enough, they certainly will have osteoporosis and other problems with the skeleton. And we focused on the adolescent problems, but late problems will be very, very severe. And also the late problems with the selenium deficiency, because they deal with a high amount of reactive oxygen species. And I'm quite sure that, for example, cancer incidence in later ages will be very high in the population. So a lot of problems in consequence of all these things in higher age will have to be discussed if this problem is being solved.
Thank you.
Yes, but there was a question before you in the last row, please.
Yeah, let me just first thank everybody for the presentation. I'm Dr. Harry and I'm Nigerian. And despite all the work done, I have a couple of problems with this presentation. Let me start from the topic. Now, it says rickets in Nigeria. Now, if you work in Nigeria, you know that rickets is not a transnational problem at all. So please, let's adjust that topic a bit. If you say rickets in southern Kaduna, it'll make more sense. Now, number two, you now say that you went through a lot of work to try and substantiate your finding. But what I think, if you had just gone through the literature in Nigeria, rickets is nothing new. A first-year resident will go through everything you've done and will still come out with the same conclusion. Rickets in Nigeria today is a sociocultural thing. It's an educational problem. It's not even that of poverty. Now, if you go through all your tests, you will notice that none of the children was actually malnourished. You follow what I'm saying? So it's more a cultural problem, and you didn't need to go through all this to prove that. I have a lot of problems with the whole gamut of presentation, but this is not the time for that. But let's just go on to say that I don't want anybody to leave here today thinking that rickets is a national problem. This is not. Rickets is not a national problem. I've lived in 3 parts of the country. Southern Kaduna is just like a point, a little point. It's just like saying you come to Gothenburg and you find a problem here, and then somebody says it is a Scandinavian problem. It's over-bloated. It is unnecessary. It's so beautifully packaged, but there's so many loopholes in it. I don't want to start talking now. All the other discussions we can talk after this. But please, let's start by first changing the topic to rickets in southern Kaduna, please. Thank you.
Next question, please.
Thank you for the discussion. Me, I'm not from Nigeria, I'm from Kenya. Dr. Alushula is my name. Now, the question goes to the surgeon who was doing the osteotomies. Now, you did not mention anything about the fibula. Did it cause any problems during your osteotomies? Because it is also attached somewhere.
Okay, definitely we osteotomized the fibula in most cases of correcting varus deformities in the tibia, and in terms of correcting the anticoagulation of the tibia, and but not in the cases where we have to derotate it. there it's not necessary to osteotomize the fibula. And if you do for varus deformity, you go high up and try to make a high osteotomy of the fibula, because otherwise you're getting problem in correction.
Okay, here's one question in the front, and then you two behind.
My name is Amran, I'm from Sweden. One question, is there any difference with rickets due to calcium deficiency or rickets due to vitamin deficiency? Or it's the same disease? Just a question. And I didn't really understand how the climate have effect on calcium deficiency in this part of the world. Thank you.
Calcepenic rickets is mainly caused by vitamin D deficiency or calcium deficiency. There's two possibilities. And it just brings up, clinically they look alike, but the treatment is very different. And that, yes, you have to do the biochemical tests to find out. And it's quite difficult because to measure vitamin D levels, you have to have laboratory facilities that are quite rarely available in Nigeria. So we had to bring the specimens to London. We tried to look in the whole Nigeria to find a university laboratory to do this for us, but we couldn't find any.
Yes, please.
Oh, she's answering the geological
I saw,
part.
excuse me, there's
For the climatic impact, or environmental impact, it's the fact that under permanently humid or seasonally humid and permanently high temperature conditions, we have very intensive weathering, chemical weathering of the parent rock. So any mineral material that is in the parent rock is solute in its molecular structures, and easily soluble materials are very rapidly washed out and not present anymore for feeding plants, animals, and finally humans. So under the actual given climate conditions, and even probably after the current models of climate change, this problem of land degradation, that's it finally, also enhanced by social cultural development, economic development, and so on in those risk areas, will be a very big problem for those populations that are living in those risk areas, not only in our place of study in actual central Nigeria, also in other Central African areas, and also example given in Bangladesh, where it's already present, or in some areas of Southern America, where it's also from the geological and climatical conditions very similar to this area we have studied.
Yes, please.
Thank you very much. I want to thank the teamwork, as you said, for this good job. You know, I come from Cameroon, a neighboring country, and I see a lot of tibia vara and all angular deformities of the knee of children. And I've done some works, but I want to say that you did not insist on the role of the sun. This paradox, we have so many deformities in area where we should not, we normally should not see, because we have sun. There is a physiological, there is the role of the sun. I conclude with when I read some publication that when there is sun, children protect against the sun. It is the reverse in Europe. People come out to take, how can I say that, a bath of sun. And in Africa, if there is sun, people go inside and protect against the sun. I think it's the first reason why we see a lot of, and I want to support my colleague from Nigeria, because I see in Cameroon we have a lot of angular deformities. It all come from an area situated at the level of Nigeria, of Kaduna, the West Cameroon. 80% come from this area. It is interesting to come in Cameroon and see whether the conditions are the same or not. The third contribution is about surgery. I used to do osteotomy. I did not multiple osteotomy, but I used to do sliding intramedullary nailing. We can give a good result, but in a long time. I have to explain that to the family. It's very a good result in femur, but it is very difficult. And I usually I did osteotomy on tibia and on the fibula. Thank you very much. My English is poor, but I speak French.
Just a few comments on that. Thank you very much for raising up the issue of the sun. It is certainly true that, especially amongst the Islamic population, we do find more rickets than among populations that do not wear this habit and have the children under their clothes the whole day. The limit for sun exposure needs to be 20 minutes per week. It's not that much that people need. So the sun issue is among the Islamic population a real problem, but the rest of the African population doesn't have it. So other reasons play a major role in it. Your aspect from Cameroon and Nigeria as neighboring countries, also thank you for bringing this up, because I have lots of contacts to doctors from Cameroon that write to me about their problems with rickets, and they do very well with just calcium distribution. They are grateful for this information, and they implement this in their treatment now. We have one partner, Nigerian partner, the orthopedic surgeon, Dr. Isaac Ego from Jos. He had worked a long time in the Jos University Teaching Hospital as well, and has now his private hospital. And he has worked closely together with other doctors that deal with rickets, and he has a huge experience with it. So in Jos Plateau State, rickets is an existing problem for many, many years, and there's already large literature that has been written up in that area by Tom Thatcher, an American family practitioner who worked with a big group in Jos Plateau State. We have patients from Kano region. We have in Kaduna State area many ethnical tribes that belong to this, that develop this problem. It's not only the Bagi tribe. We have now at least 11 different tribes that come up with the problem, and it is a starting point. It is not to offend a region or a country. It is to bring up and to rise up a topic that there is a dramatic impact of health for children that can be treated with a very simple option. This is our message we want to bring through, and really not to offend any country, certainly not. It is just the beginning of a huge problem that we are facing, and we want to raise this as an opportunity that we have already found solutions for it.
Yes, please.
Thank you very much for the presentation. I'm a young Nigerian surgeon. I just a few comments before some questions. It always my name, by the way. I'd like to state for the benefit of everybody that Nigeria is a huge country. It has a population of about 150 million. Kaduna State itself is one of the 36 states. It's not the largest. I was just checking the internet now. It has a square mile, area cover of 46,000 plus kilometers square and population of about 6 million. 27 children were presented in the study. And I was wondering, was there any sampling performed to sort of see the prevalence in the area, or what's other factors may be responsible? Because previous studies done by Nigerians and by people who have come from overseas have actually shown that it's more of socio-cultural and nutritional than anything else. I also looked at the sampling that you did. That was in 6 villages in Kaduna State. And like I mentioned before, in an area of 46,000 square kilometers. I was wondering how that was spread out and what was the indication to take the soil sample in those areas. Was there an epidemiological study done prior to that, and then you were taking specific sample from those areas where the deficiency was found? The other bits that I have is, as to the diagnosis, I'm sure 1 or 2 people have raised that issue. Practicing physicians will actually tell you it's very difficult to make a clear-cut diagnosis of rickets, especially, in children who are older than 5 or thereabout. Someone mentioned something about bone biopsy before. We were comparing a bone biopsy, I assume it was pre-operatively and post-operatively, and with medical treatment. How many of those patients actually had bone biopsies, and how many actually pointed to rickets based on the histopathological findings? The other thing I want to find out is whether you consider doing assessment of vitamin D receptors. There was a column here about genetics and gene environmental influence on the development of rickets. What sort of genomic studies or what sort of biochemical studies were done to actually see what interactions were taking place? Then the last question I have is, I think it's still related to the angular deformities. Many practicing physicians in developing countries would, frown at some of the pictures that were shown, which shows gross angular deformities. Too gross. I tend to agree with when you have the windswept deformity. A lot of people believe that's classical of ricket, but a lot of those things look more like metaphysia, epiphysia dysplasia, rather than anything else. Thank you.
I would like to comment on some of your points. For the epidemiological data, the initial visit was carried out in 11 different villages, not 5. And altogether, we have now 55 villages that we do the investigations in. And epidemiological data are difficult to take because we don't know anything about real population data. If you ask in Kaduna State for population numbers in areas, you do not get sophisticated material. So we can only estimate the incidence of clinical rickets in children. And we came to the conclusion to measure this in between 35 to 40% of the children's population in Kaduna State. There is literature carried out by also Nigerian researchers that say that the incidence of rickets in Nigeria is between 7 to 10%. So remarkable high number already. And in that area, as a hotspot area, it is markedly risen due to different aspects that we brought up in our symposium. The question about, what was the last part? Yeah, genau, you should add that, yeah. Mm-hmm.
So for the part of physical geography, you're right. We had just studied areas of 6 villages. That was this part of the presentation in all. And it was just the first study. So as we heard about the problem, we made our hypothesis on the basis of literature and geological mapping. And then we had just 3 weeks in the field with our coring equipment and everything. And so we, for the organization, logistical and administration part, we were depending on the help of this health station, Hope for the Village Child, and their connections. So we went to some of the very severely concerned villages, by rickets, for sampling there, and 1 comparison village. And it was not possible to do more studies for this first study for the student that was with me. And we will continue the project also for getting more reliable, statistic relevant data furthermore. But the hypothesis went completely together with the sampling results.
It's excellent that you ask for more data. That is also what we want. It is just financial restrictions which keep us away from doing more research that is necessary to point out this problem. And I wish that we find other stakeholders in this auditorium today to help us.
What sort of help you want?
Pardon?
What sort of help you want?
Well, I mean, if you come from India and you see also other rickets cases in India and you seem to have access to biochemical measurements, proper biochemical data, it would be wonderful to have other information from other areas. What is the problem there? What is the rickets like background in your country or in your neighboring country? And do you see any impact with just treating patients with calcium, for example, as an information? Because we start this already, and we come across with many good answers from other doctors. That's
We as clinicians see patients coming with a problem directly. About epidemiological studies, I don't have much information. But when they come to our hospital, I have very severe variety of back pain, and ultimately they turn out to be patients of rickets, severe kyphotic deformity of the sacrum.
yeah.
Such like cases, and from a clinical practice, if you want, we can send you away.
Excuse me, before we leave, on behalf of the organizing committee, I would like to thank the moderators for this important symposium. So I have a small gift, but heavy, from Sweden to Krista.
Thank you so much. Thank you very much. Share this.
Last comment.
Yeah, we are very much behind. Thank you very much for attending this session. I think you have done an excellent work, important work. I mean, what is special in this disease is the children are like outcasts. And this is so simple, with simple measures to heal the problem. Thank you very much.
I can send you a total study of 1,000 patients of vitamin D and calcium metabolism.
Yeah.